Just like you heard Professor Kim introduce me, my name is Dr. Simeon, and this morning I'll be taking you on cyber cognition mechanisms for the security of autonomous intelligence systems. Just like you know, in this presentation, we just have three major objectives we'll be looking at. Number one, it is to help you to understand the different levels of security in any system, because most time people misconfuse these levels of security, especially as researchers. Then also to discover the different approaches to addressing these security issues. And then finally, we'll be looking at the role of convergence-based technology to ensure optimal security. And while we are ensuring optimal security, we don't want to look aside from the aspect of sustainability, because increase in security can also contribute to systemic issues. So let's dive in and we look at. Now there will be an overview, then we'll look at the different security threats, and then we'll look at security intelligence in autonomous intelligence systems, and then we'll look at the different convergence-based approaches, as well as case studies of the researches we have done, I particularly and my team, and then we'll look at the dilemma of convergence approach, and then we conclude with some recommendation on what you can do. So first, just sit back and watch this 7 minutes short video to summarize the lecture. Thank you.
Self-driving vehicles, also known as autonomous intelligent vehicles, AIS, are no longer science fiction. Autonomous vehicles can be in the form unmanned ground vehicles, UGV, unmanned aerial vehicles, UAV, and unmanned marine vehicles, UMV. They promise a future with fewer accidents, less traffic congestion, seamless navigation of difficult terrain, and increased mobility for everyone. However, this promising future hinges on one crucial aspect: security. Imagine a world where our cars or drones could be hacked, potentially causing accidents or even being used as weapons to target individuals and buildings. This is the challenge we face. The transition to autonomous vehicles relies heavily on complex systems like artificial intelligence, which controls the car's movements, and communication networks, which allow the vehicle to interact with its surroundings. These systems, while revolutionary, present tempting targets for hackers. A security breach could have disastrous consequences, ranging from data theft to life-threatening situations. Ensuring the safety and security of autonomous vehicles is not just an option, it's an absolute necessity. We need to build robust security measures into the very fabric of these vehicles. This is where the convergence of AI, blockchain technology, and zero-trust architecture comes into play. These technologies, working in unison, offer a comprehensive approach to securing autonomous vehicles and paving the way for a safer autonomous future. One of the most pressing threats to autonomous vehicles is hacking. Malicious actors could potentially exploit vulnerabilities in the vehicle's software to take control, steal data, or even cause physical harm. This is where AI comes in as the first line of defense. Think of AI as the car's or drone's immune system. It can be trained to constantly monitor the vehicle's systems, detecting and responding to threats in real time. AI algorithms can analyze patterns, detect anomalies, and even predict potential attack vectors before they happen. This proactive approach is crucial in the fight against sophisticated cyber attacks. Furthermore, AI can play a crucial role in enhancing the vehicle's decision-making processes. By analyzing data from various sensors, AI can help the car make safer and more efficient decisions in complex situations. For example, AI can help the car anticipate and avoid potential collisions, navigate through hazardous road conditions, and even make split-second decisions in emergency situations. However, it's important to remember that AI is not a silver bullet. Like any technology, it has its limitations. Hackers are constantly evolving their tactics, and AI systems need to be continuously updated and improved to stay ahead of the curve. Hence, deciding the best type of AI model to adopt is important. The key lies in developing robust AI systems that can adapt and learn from new threats, ensuring the ongoing safety of autonomous vehicles. Autonomous vehicles generate massive amounts of data. This data is essential for the vehicle's operation, but it also presents a valuable target for hackers. Imagine the consequences if someone tampers with this data, leading to incorrect decisions or even system failures. This is where blockchain technology comes in. Think of blockchain as an incorruptible digital ledger. It provides a secure and transparent way to store and manage data, making it virtually impossible for hackers to tamper with it. When applied to autonomous vehicles, blockchain can be used to create a tamper-proof record of all the vehicle's data, including sensor readings, location data, and even software updates. This tamper-proof record is crucial for ensuring data integrity. If any data is compromised, the blockchain can be used to instantly verify the authenticity of the information. This not only helps prevent malicious activities, but also provides a reliable audit trail for investigations in case of any incidents. Moreover, blockchain can facilitate secure communication between vehicles and infrastructure, enabling the exchange of critical information in a safe and trustworthy manner. By ensuring data integrity and secure communication, blockchain lays the foundation for a more reliable and trustworthy autonomous vehicle ecosystem. It provides the assurance that the data used by the vehicle is accurate and untampered with, contributing to the overall safety and security of the system. Deciding the type of blockchain network and algorithm is a factor for AIS. Zero trust architecture. Trust no one. Verify everything. Traditional security models often operate on the principle of trust but verify. This means that devices or users within a network are generally trusted until proven otherwise. However, in the context of autonomous vehicles, this approach is simply not enough. A single compromised device or connection could have catastrophic consequences. This is where zero trust architecture comes in. As the name suggests, zero trust architecture operates on the principle of trust no one, verify everything. In this model, no user, device, or connection is inherently trusted, regardless of its location or previous interactions. Instead, every access request is rigorously verified before being granted, ensuring that only authorized entities can access sensitive data or systems. In the context of autonomous vehicles, zero trust architecture means implementing multiple layers of security, including strong authentication mechanisms, data encryption, and granular access controls. This ensures that even if one layer of security is breached, the others remain intact, limiting the potential damage. Zero trust architecture is not just about preventing attacks, it's also about limiting the impact of successful breaches. By segmenting networks, enforcing least privilege access, and continuously monitoring for suspicious activity, zero trust architecture helps contain breaches and prevent them from spreading throughout the entire system. Conclusion: the road ahead. The road to a future filled with autonomous vehicles is paved with both promise and challenges. While the potential benefits are undeniable, we cannot ignore the security risks associated with these complex systems. A single intelligence mechanism is not sufficient to provide optimal security. By embracing a holistic security approach that leverages the power of AI, blockchain technology, and zero trust architecture, we can mitigate these risks and pave the way for a safer and more secure autonomous future. AI acts as the first line of defense, constantly monitoring the vehicle's systems and responding to threats in real time. Blockchain ensures data integrity, providing a tamper-proof record of all the vehicle's data. Zero trust architecture strengthens the overall security posture by verifying every access request and limiting the impact of potential breaches. The convergence of these technologies is not just about securing individual vehicles, it's about building a robust and resilient ecosystem for autonomous driving. As we continue to develop and deploy autonomous vehicles, it's crucial that we prioritize security as a fundamental design principle. By doing so, we can unlock the full potential of AIS and create a future where transportation is not only more efficient, but also safer for everyone. But optimal security must not be sacrificed for speedy decision-making and sustainable usage of innovations.
Okay. So the video you just watched is a summary of what we're going to be looking at, in as much as it focuses on autonomous intelligence systems that is the security intelligence that is applied to it. However, the lessons gained can be applied in any area of research that has to do with security. So it's just to limit the focus to this aspect, but the knowledge can be used wherever you are carrying out a security research. Now, first of all, if you look at what the video talked about, most time when we talk about autonomous vehicles, where people's mind just go to is a driverless vehicle on the road, but it encompasses something much more than that. It goes beyond a driverless car because it has to do with transportation on the land, the air, and even the sea. So whatever that is applicable on the land can also be used in the air. So first of all, let's look at AIS security threats. And in this section, we'll look at the categories of security threats, their behaviors, and then we'll look at layers and then the taxonomy. Now, simply, when we talk about security threat, it's simply a disruption of communication. That's all. That's a summary of what security threat is all about. And most times, it is targeted at the communication network through hacking. As you can see, this is the report of various kind of security threat that happened using drone, specifically in the United States of America, across the 50 states, between 2022 and between 2020 and 2024. And you can see the summary there, around 14.2% attacks in 2020, 10% attacks between 2021 and 2023. And as at first quarter of 2024, there's already 11.3% attack. And then you begin to wonder, despite all the technologies in place, why all these security threats? The reason is because the guys who are always doing this are usually ahead of researchers. So researchers need to think out of the box. Now, summarily, whenever you talk about security threat or what is known as attack, is divided into two broad categories. The passive attack, the active attack. And the reason why you need to know this is the way to address active attack is different from the way to address passive attack. If you use the approach of passive to address an active attack, you will miss it all. You will miss it. And eventually, you won't get the result you wanted. So no matter the name of the attack, it falls into either active or passive attack, as you can see the summary there. In passive attack, it's not after destroying anything. It's just simply to steal information. So, as you can see, that's the summary there. Now, no matter whether it's an active or passive attack, most attackers have 5 major intentions or behaviors when they're attacking a system. It's either to deny access, which is what most people call, which is generally known as a denial of service, or it could be to deceive the user, or what we generally call in security spoofing, or it could be to duplicate what is generally known as worms or spams, or it could be to delay response, delay response, which most time we call it jamming, and one of the most prevalent attack there is the man in the middle attack, or it could be to distort, that is to steal information, which most time we call it either a zero-day attack or interceptive attack. So whatever name of the attack, it falls either, the intention of the attacker is either of these 5, to deny access, to duplicate, to deceive, to delay, or to steal. So, and the reason why you need to know these broad categories is because every attack has its own target. And therefore, when you are trying to mitigate an attack, you must be able to find out which of these categories does this attack belong to, so that you know how to go about solving it. Now, generally, attack usually focus on different layers of a system design. Most time when people say there are 3, I'm working on a research on security, question I ask, what aspect of the system design is this attack targeted at. Hence, when you are carrying out a research to address a security issue, you need to ask yourself what aspect of the system design, using the OSI model. Is it the application layer? Is it the presentation layer? Is it the session layer, transport layer, network layer, or is it the physical layer or the data link layer? Knowing the layer of the system that the attack is targeted at will help you to know how to carry out your design. Now, let's look at the broad taxonomy of attacks in AIS, that is Autonomous Intelligence System, with a bias on drone, that is UAVs. That's area vehicles, not land vehicles. But whatever that is applicable in the area is applicable in the land and also applicable in the sea. So generally, attacks, security attacks on UAVs is usually in 3 different layers. It's either the UAV communication layer or the UAV communication architecture or the UAV component. Now, as you can see summarized in this table, the UAV communication attacks can be targeted at the network layer or the transport layer or the physical layer. And you can see their sub-targets and their specific names. You need to know these attacks, their characteristics, and how they operate. That will help you to be able to design something that will be able to address it. Simply saying, I am addressing a security issue without finding out which layer is it targeted at and what is behavioral aspect, you are just wasting your time, because what is applicable to A may not be applicable to B. Then for the UAV communication architecture, we can see the different type of attacks, whether it is a U to U, that is UAV to UAV, or UAV to GCS, or UAV to satellite. Each of these attack, the way an attack behaves for a UAV to GCS is different from the way an attack behaves to UAV communication. And then also, UAV attacks applies to different components, physical components of the system, hardware-based attacks, software-based attacks, and sensor-based attacks. Understanding these key things are very, very important. Now, because these attacks have different characteristics, no single security intelligence mechanism can address all attacks. Most time people say, I have designed something that can address security attacks. I say, no, you have not designed what can address security attacks. You have only designed something that can address a specific kind of attack, targeted at a particular layer of the design. Because it does not always, a single mechanism is not a silver bullet, just like you heard in the video. Now, so let's move straight away and look at how you address attacks as a security guy who is carrying out research. Now, we'll be looking at 2 major things here. We'll be looking at what we call the CIA security triad, and then we'll be looking at the different type of cyber cognition mechanisms that most researchers use in addressing attack. Now, simply, whenever there is a security design, there are 3 major things. Every security is designed to either improve confidentiality, improve integrity, or improve availability. And most times, every attack is targeted at either of these 3 things. So when you say you are carrying out a research to address a security attack, the question I always ask is this: what aspect of the security are you trying to improve? Is it confidentiality? Is it integrity? Or is it availability, as you can see on screen? Confidentiality has to do with authorization, making sure that the person that is authorized to access a particular data is the one accessing it. Very, very important. Then integrity has to do with accuracy and trustworthiness, making sure that what you are accessing is the right thing. And then finally, availability has to do with time. Whenever you talk about availability, we have to do timely access, accessing it as when it's supposed to, Are you supposed to access it within 1 second? And then something has come in, and then you are accessing it between 1 second and some little addition. Then you need to be wary of that. So whenever you are addressing a security, whenever you are designing a system to address security attack, you need to ask yourself, am I targeting confidentiality issue? Is it an integrity issue? Or am I looking at an availability issue? So like I said, the goal of cybercognizant architecture is to either achieve all of this or any of these. And achieving any of these or all of this simply means improving security. So when you say your system has improved security, you need to ask yourself, is it C, I, or A? Or is it C and I? Or is it A and I? Or is it three of them combined together? Now, let's look at the different security intelligence architecture people normally use. These days, we all know AI. Everybody, AI, I've done this. Now, when you talk about AI models are usually divided based on the type of data, the volume of data, the complexity of the data, and the hardware/software configuration where you're going to deploy your model. Very, very important. In your choice of an AI model, you need to ask yourself, before I decide I want to use, for instance, what is known as autoencoder, you need to ask yourself, what type of data am I going to, does the system interact with? And then what's the volume of the data? What is the complexity of the data? And then the way I'm going to deploy my model, okay, what is the hardware deployment configuration? Can it take my model? And that is why, as you can see on screen, I'm using what we call the anti-drone system model to classify the AI model. But generally, this is what your AI models are divided into, a broad category. Is either a reinforcement learning model or a regression model or what we call classification model. These are the three major models of AI. It's either it is this, no matter the name you call it, whether you are calling it YOLO or you are calling it RNN or whatever you are calling it, these are the different type of tasks they perform. It's either a reinforcement task that does not need historical data, okay, or is a regression task that has to do with time series analysis, okay, event that changes with time per second, or milliseconds, or classification, either yes or no, true or false. So whichever category of AI, before you decide which model you're going to make use of, you have to ask yourself the following questions. What is the type of data that I'm going to use? Do I need a historical data? If I need a historical data, then I'm not talking about reinforcement learning here. Once it is historical data, and you know the meaning of historical data, you are learning from past, data. Because reinforcement learning has to do with trial or error. There's an agent, and which is where AI is going into today. Now, the volume of the data, how large is the data? The complexity of the data. Once data complexity increases, then the normal classical AIs cannot do that. That is where you need your network, artificial neural networks. That's where they all come in. Whether you call it RNN or CNN or whatever you want to call it, that is where neural network do their job. Okay, so let's move ahead. Now, this is an example of an intelligent system for AIS. We call it a software-defined radio. This is an architecture. And as you can see, what a software-defined radio does for UAV communication is that it helps to elongate communication of UAV. Most time, UAV uses short communication. So, but with a software-defined radio, the UAV can travel a long distance. And that is why these days you can use UAV for logistic delivery to go to a far distance because of software-defined radio. Now, as you can see on screen, this software-defined radio, for it to work efficiently, it has to make use of different sensors. And these different sensors, as you can see, RF, radar, acoustic, optical. These are different types of data. These different types of data now, one single AI model may not be able to do the job. And that is where multimodal AI models comes in, to be able to make sure that this guy work efficiently. And once multimodal has to come in, then it simply means that system complexity will increase. Because multimodal has to do with convergence. System complexity will increase. So you want to ask yourself, where I'm going to deploy this guy, can the hardware be able to take it? Now, not only that, these are just different types of software-defined radios that are available today, and the ranges that they can cover in helping the UAV to move very, very fast. Each of these software-defined radio has higher level of security, as you can see, the way they are. The more function they can carry out is also the more the security technology increases, and also the complexity of the technology also increases, and of course, as we will be seeing later, some other things also increases. Now, for blockchain, just like you saw in the video, when we talk about blockchain, simply AI generates the AI helps you to inference on the data, to learn from the data. However, have you ever asked yourself the question, the data that AI is learning from to be able, for the system to be able to take a decision, how accurate are those data? Who is supplying the data? What if the data is manipulated? Because AI has no way of checking when the data is manipulated. All AI knows is that data has come in, then I need to work on it. Blockchain comes in to make sure that before the data comes in, we want to be sure that the guy who is supplying the data is the right guy. And that's summary of what all blockchain does for us. So blockchain helps to protect the engine room, the intelligence hub, which you call the AI, such that the decision that the autonomous intelligence system is taking is reliable, is trustworthy. Because if the decision is not trustworthy, then it can lead you astray. So blockchain comes in to provide speedy, scenario-specific, sampled, solidified, see-through, and sealed or tamper-proof operation. What this simply means is that when blockchain comes into an AIX, you don't want the introduction of blockchain to delay the decision making. When there is a delay in decision making, for instance, a car needs to take a decision, and then the blockchain and it's going to take that car just within one split second. Once there is a delay because of increase in security, the car might collide with another car. So when you are bringing in blockchain into an AIS, take note, speed is very, very important. Speed is very, very important. Now, to mitigate security threats in AIS, blockchain achieves the following principle, especially in all UAV, in UAVs and other, AIS, seamless user authentication. We want to make sure that every user in the network is authenticated. Not only that, navigation authorization. To ensure that the route, the path the UAV or the car is going to take is the right navigation area. And then finally, communication availability. Now, this is an example of a design, a blockchain enabled UAV logistic authentication. What we try to do in this research is, when a UAV is in the air, how can you identify that the object the UAV is carrying, maybe to deliver, is the right object? How do you identify that the object is not a smuggled object? Is not carrying a nuclear weapon? Is not even carrying what we call a network jammer? I don't know how many of you who knows about network jammer. That when someone comes in here with a network jammer, it freezes the network here. And most time when a network is freezed, it's because someone wants to steal something within a split second and then releases the network. Many times people don't know that network freezing just happens within maybe just 1 second. And within that time, there is, everybody is wondering what's happening. And before you know it, your phone starts working. Someone has just stolen a sensitive information around. So what we try to do in this work is to make sure that when a drone is delivering something, we want to check the source, the package, and then the user. The source will mean the transportation or the logistic company that owns the drone, then the operator of the drone itself, and then the package the drone is carrying. That's what we try to do in this research. And at the end of the day, even before the drone goes into the air, a blockchain can help us to be able to detect the authenticity of the package, the operator, and the source of the drone itself. Now, you need to take note of these 9 requirements for application of blockchain in AIS. For those of you who are interested in going into AIS, security intelligence research. When you bring in blockchain, you must make sure that data integrity is improved. If data integrity is not improved, there is no point bringing in blockchain. Just use your normal, physical security architecture. Number 2, interoperability. Interoperability simply means the system must be able to seamlessly integrate into the existing system. The blockchain you are bringing in, once the blockchain you are bringing in is going to affect the existing legacy system, then guys will not be able to accept whatever you are doing. You have just done your research. Your research is fine, but it's not usable. Then not only that, intelligent automation of smart contracts. The person that took the seminar last week told you about this aspect of smart contract. These days, there is what is known as smart contract exploitation. Smart contract exploitation. So your blockchain must be able to also identify what we call supply chain attacks. Must be able to help to prevent it. And then inclusive data privacy, protection, informative monitoring, scalability, that is, as the system users increase, network performance must not decrease. And then it must also fit into regulatory compliance and, of course, cost effectiveness. This is a research we did where we are trying to come up with a cross-layer blockchain security architecture for AIS network. As you can see, in this work, we try to make sure that the blockchain addresses or fits into the different layers of the system design and has the ability to detect different types of security attacks. It has a way of identifying it, and also it has a way to ensure that there is a scalability as the system, as the system complexity increases, so that at the end of the day, whether it is navigation or user authorization or even what is known as defense control. What we mean by defense control is that there are organizations that are in charge of making sure that any drone, for instance, that is not duly registered is not allowed to fly even before it gets into the air. So the blockchain, in this work, in this research, we try to come up with a design that can get this done. Now, just like you asked, zero trust. Some of you might be hearing zero trust for the first time. But zero trust has come in to change our narrative from the normal security way to a new way of doing things. Now, the normal security way has to do with, okay, for instance, let me use blockchain. Okay? In blockchain, before blockchain comes in, the way we analyze security is that we trust the system. So we accept whatever it gives us. We trust the users of the system. So as long as I know you, then we work. When blockchain comes in, blockchain says, I don't need to know you. So the emphasis shifted away from the users of the system to the system itself. We trust the system itself. Okay? Now, so since we trust the system, it's allowed. Zero trust architecture says we cannot always trust the system. Especially these days, there's what we call adversarial AI attacks. That is, AI is being used to attack AI. So even the system that you are trusting is no longer trustworthy. And that is where zero trust architecture comes in. Zero trust architecture says we don't want to trust anything. Just verify. Verify even the AI you are using. Just like some of you now that uses ChatGPT, right? You ask ChatGPT question and ChatGPT gives you an answer, and then you start using it. You don't try to find out this answer that ChatGPT is giving me, how reliable is it? And you start running with it. So in zero trust architecture is a new paradigm in cybersecurity intelligence. Says don't trust even the blockchain itself. We need to verify everything. And why this is important is that just like in AIS, it's an enterprise system. It's a collaborative system. It simply means that the network are dispersed in different places. You are depending on, you are getting information from this vehicle, you are getting information from the satellite, you are getting, how reliable are all these places? So with zero trust, we verify everything and we don't trust anyone. And zero trust simply uses what we call a multi-layer, a multi-factor authentication. And the adoption of zero trust is still in an early stage in AIS. It simply means that if you are doing research in this area and you bring in zero trust and you give us ways of bringing in zero trust into AIS, you are creating a niche for yourself, if you understand what I'm talking about. Now, in this research here, we'll try to show how zero trust can be applied in UAV, security intelligence. Now, this is generally the logical component of a zero trust architecture. We have what we call the policy engine or the policy decision point, which is made up of the policy engine and the policy administrator. And then they interact with what we call the policy enhancement plane. And using that together, you can verify every aspect of the system. If you want to know more, you can read our papers on this. Now, something that is very, very crucial with zero trust application, especially in AIS, is the problem of continuous monitoring. How do we develop a system that can monitor the security threat continuously, especially with changing operational dynamics? Since zero trust is multi-layer and multi-factor, as the operational dynamic changes, how can we do it in a very speedy way without constituting any delay? Because a split-second delay is catastrophic. This is a research issue in application of zero trust in time-critical systems, especially cyber-physical systems that are not just precision conscious, but time conscious. So, a research area for you if you are coming into this, if you're interested in this area. There are 7 major considerations if you are going to use zero trust in AIS. And I've just summarized it for you on the screen. All data sources and computing services must be considered a resource. What that simply means is that every data and every point in the system must be seen as a critical component that contributes to the overall system security performance. You don't say that one aspect is very minute, we don't need it. No, because it's an enterprise resource system, okay? And since it's an enterprise resource system, every data coming from different sources must be seen as a resource. Not only that, all communication must be secured regardless of the location. There's nothing like this is the authorized person, this is the person that is in charge. No, nobody is in charge. Everyone that is in charge is even a suspect in zero trust. So every communication must be secured. Access to individual enterprise is granted on a per session basis. It simply means that when we verify you the first time, and you coming into the system and you are participating, at every point in time, we keep verifying you because we don't know whether you are being compromised. So at any instant you are compromised, you are quarantined or you are censored so that you don't, compromise the entire system. Access to resource is determined by what we call the dynamic policy. Not only that, the enterprise monitors and measures the integrity and security posture of all owned and associated assets, and all resource authentication and authorization are dynamic and strictly enforced before access is allowed. Just like in the case of the drone, the design we talked about. We don't authenticate the drone while it is in the air. Immediately you trigger your drone, then the system monitors it, irrespective of wherever you are. Immediately you trigger it. The reason is because you are in a network and you have a MAC address. So immediately you trigger the drone, we already dictate that this drone is illegitimate and it is jammed, even before it gets to the air. Now, and then finally, enterprise collect as much information as possible about the current state of the assets, the network infrastructure, communications, and uses to improve security posture. In zero trust architecture, every time we are doing inferencing on the data, unlike the normal AI that it learns and then it starts using that one, in zero trust architecture, we don't depend on your past experience. We compare the past with the present at every split second. So it's a system that keeps running and running and running because information keeps changing. Now let's look at some case studies of research we've done where we applied some of these things, and we just quickly look at two. Number one, we have what we call the DC Bander. The DC Bander is a decentralized collaborative blockchain assisted network for drone authentication. In this research, we made use of three major models. One, the DroneNet model that we used in detection of drones and identifying the object the drone is carrying itself. Then we have the Alien model. In the Alien model, we try to authenticate in order to check the legality of the drone, if the drone is authorized. We also check the proximity of the drone. That the proximity, a drone can be in the air. We want to check its proximity to where it is meant to operate. For instance, you understand that there are some area where there is mapped out a drone is not meant to fly into it. So the Alien model is designed to be able to check the proximity of the drone, such that if the drone is not even allowed to, the drone is allowed to fly, but the object the drone is carrying is very, very hazardous, then it can be mitigated on time in order to curtail the security threat is going to, that is going to incur on maybe an infrastructure or where people are. And then finally, the Alien also neutralizes the danger. Because when a drone is illegal, but is not carrying an object that is harmful, we don't need to destroy the drone. We can disengage the drone into an area. Then finally, the third model here is the bander itself that authenticates and validates the source of the drone. So as you can see, this is a very complex system because it makes use of different models, and at the same time, it makes use of different sensors and different hardware requirements. You can imagine what we must have done in this research. Now, these are some of the outputs. As you can see, showing when the drone was detected and the detection points, and then the proximity. You can see 85 meters away, 50 meters away, 84 meters away, and what have you. So it's not just showing us the drone itself, it's showing us that this drone is carrying something. It's carrying an explosive, or it's carrying, it's carrying a logistic material. Then how close is the drone? And then look at the blockchain aspect of the design, showing us, the split-second decision for the authentication to be able to arrive at the decision. These are some of the works we've done in this area that is already published. Now, let's look at the second one, the second case study, that is the synergistic advanced cross-layer architecture for drone security. Like you must have heard, I'm a drone security expert, so that's why I'm using drone as an aspect of AIS to do this. Now, in this design, we try to do a holistic design. We came up with a holistic design that also incorporated AI, the blockchain, and the zero trust architecture. Now, as you can see for the AI is already a complex design on its own. It makes use of what is known as the explainable AI to be able to guarantee reliability of decision. And you can see it controls different aspects of the system, the perception, the planning, and the control. And then the cross-layer, architecture of the blockchain carries out the cryptographic, functions to ensure that the right user is the one sending us, is the one feeding the data to the AI, and the AI is sending back to it. So there is a back and forward authentication, as you can see, a back and forward. So it's not a one-way authentication. Okay, the result we have gotten is okay, and then we keep using that result, not checking whether the result has been compromised. So that's what we try to achieve here. We try to use explainable AI, and then we try to use the blockchain, of course, an energy efficient blockchain, as you are going to learn later, and then we incorporated it into the the zero trust architecture, and it's a continuous process. At every split second, we keep getting this result. Now, whenever you use convergence approach, something comes on board. Something comes on board, which we call the SSS trilemma burden. And we're going to, part of this class is to help you to know how to address this when you are carrying out a convergence-based design. Now, let's look at the problem that convergence-based approach normally have, whether it's in AIS or any other place. Once convergence approach comes in, there is increase in computational cost, increase in implementation cost, maintenance cost, even usage difficulty, and then there is now exposure to more attacks. You are trying to solve a security threat, but by bringing in convergence, approach, you have increased the system to more vulnerability, and then, of course, commercialization cost. What does that mean? You don't want to design something that cannot be implemented. You design something, and the guys who are not going to manufacture it comes up and say, wonderful design, but it's not usable. Because by the time we implement this, nobody wants to patronize it. So convergence-based designs always have this issue. Now, because of this issue, just like I said the other time, look at the DC bander. Can you imagine to be able to maintain this type of design? Can you imagine to be able to implement this type of design? Can you imagine to be able to maintain this type of design? Then you can even imagine the usage. So this is the trilemma of a convergence-based approach. There's always an issue of how do we increase confidentiality at the expense of accuracy, at the expense of availability or access. Very, very important. It's always an issue. This is a trilemma. So we want to maintain speed. We want to increase security. And at the same time, we're also conscious of scalability. This is always an issue in convergence-based approach. When you are improving security, I've improved the security, but the speed has gone down. I've improved the speed, but scalability has gone down. So you always want to maintain a balance. So in doing this, there are three key challenges: high security versus speed, high speed versus scalability, high scalability versus security. This is always a challenge when you are using convergence-based approach. For instance, a blockchain-based AIS always faces the issue of maintaining a balance between security, decentralization, and scalability. A cloud-based AIS security always faces the issue of access, scaling, and data protection. And a multi-factor authentication AIS always improves security but slows down the user experience. So it's always an issue. How do you maintain balance in this? And that is where CII comes in. While we are doing this, like I told you, at the end of this seminar, whatever the area of research you are doing, when you bring this into focus, then you will be a good inventor. Most times, many inventors are not good innovators. An inventor is someone who discovers an idea, but an innovator is the guy who sells the idea, and the idea is known everywhere. So most times, many researchers are not good innovators. So to be able to solve the trilemma of computational cost that is introduced by convergence approach, CII is a very, very wonderful thing you should look into, because CII makes you to think like an innovator, not just an inventor. And that is what is known as connected innovation intelligence. And like I said, it has to do with commercialization of your idea. Now, so whenever you are using conversion-based approach to address a security issue and you bring in CII, you want to make sure that your design is systemic. There should be seamless integration into the existing platform. It should be cost-effective. It should be user-friendly. The user should be able to easily approach it, and they like it. It should be flexible. It should be flexible. And then finally, energy efficient. If it is not energy efficient, if it's going to incur more costs in terms of energy, nobody wants your design. So take note of this, what is known as, we call it the Scoffy principle of the CII approach to address, convergence-based issues. Now, there are 5 major strategies for addressing this using CII. You want to make sure that your design is layered security design. That's number 1. And you want to make sure that even if you are introducing what is known as cryptography, maybe in subsequent seminars you'll be taught about quantum cryptography, that has to do with the hashing function, encryption of data, at different layers depending on the dynamics of the data. You want to make sure that you don't just bring in a cryptography function, but it must be optimized. Then smart scaling. You want to use either what is known as load balancing and caching, which is a topic on its own. And then you want to make sure that your design is collaborative. That is, what we talk about here is that when you want to use an AI model, you don't just say, I'm going to use a CNN. Why CNN? You want to use advanced AI. For instance, in AIS, we don't just use CNN. We know that the network is on the edge. So data privacy is needed. The first thing that comes to the mind is federated learning, edge AI. And even when you are using these guys, it must be tiny ML. That is something that you can deploy on a microchip as little as your device is. And then even if you are using CNN, you want to use what is known as transformers. Transformer like the COMNES algorithm or the DIT algorithm. These are CNN that are meant for small devices, not just the normal CNN everybody know, like YOLO, like VGGs, and the rest of them. Not even mobile nets. There are newer models. And then you also want to make sure that your ZTA is applied to minimize trust. So, just like I put here, basically for blockchain, for those of you who are into blockchain, take note of this. Very, very important. To be able to, to address trilemma in a blockchain-based design that is applicable in AIS, you want to make sure that you bring in layer 2 scaling, or what is known as sharding principle, or like, then we have the hybrid consensus mechanisms, just like we in our lab, we now have the POA square, that is the proof of authority and association, which improves, energy efficiency, you can bring in sidechain or zero proof, zero knowledge proof, and then AI-driven smart contract intelligence. For those of you who are into blockchain, anytime you are bringing blockchain into an autonomous system design, you want to ask yourself, did you bring in any of this to address, the security issue and not just the mainstream blockchain consensus algorithm? Now, we're coming to the end of the lecture. As someone who wants to go into a security intelligent design in order to address security attacks, there are 7 major questions you need to ask yourself. And this cuts across whatever area of research you are doing. You want to ask the first question: what type of security attack am I addressing? Is it a passive attack or is it an active attack? Then what category of the security attack am I working on? You remember the 5 Ds. Is it to deceive? Is it an attack that is meant to deceive or to deny access or the rest of them? Then what layer of the system is the attack targeted at? Remember the 7 layers: the data link, the application, the presentation, the physical layer, the session, the network, and the transport layer. Then you want to ask, what aspect of the CIA am I interested in to improve on? Is it authorization, accuracy, or access? Or do I want to improve 3 of them? Or do I want to pick 2 out of the 3? It's very, very important. Then how do I achieve a trade-off between security, speed, and scalability? It's always a question you must ask, because a single design cannot address all of them, except you want to. It may, but you want to ask yourself, which aspect, how do I maintain balance between security and speed, security and scalability, and then what is the best combination of models that will help me to achieve my convergence? Remember the 3 principles. And then finally, how can I integrate CII for sustainability of my security design, such that when the design goes out there, then, because once an invention does not become an innovation, it is useless. Once an invention is not an innovation, it's useless. I want to say it again. Once an invention cannot be implemented for the large-scale production, it is useless. So in conclusion, we've just learned that security issue in AIS is usually targeted at its communication network, and it affects all its layers. Security intelligence architecture designs must address at least one or all of the concerns associated with the CIA principle. A single intelligent design cannot address it because different security attacks have different behaviors, and the convergence approach is needed for optimal security. However, it introduces cost. Hence, adopting CII principle is crucial to be able to address the computational issues that is associated with a convergence-based approach. What are the ways that you can use zero trust to improve and accelerate AIS? You need to hold that as a question. How can you bring in newer AI models that can seamlessly fit into AIS in order to address emerging security issues? And then, how can quantum cryptography be applied in AIS? These are key areas you need to think of. The reason is because the normal classical AI makes use of historical data, past data. And security attacks don't really come from the past, they come from the future. So how can we bring in quantum application into AIS? Exploring these concerns will lead to sustainable and safe AIS, and of course, comprehensively any type of security intelligence. On this note, I want to say thank you for coming to the class. I want to know if there are questions. I will entertain it now. Thank you.